Hello students, see this question from IIT JAM. So in this question, a n-type semiconductor is given, and for the semiconductor, they have given one plot versus log of conductivity versus inverse of temperature. Okay, so as you can see in this plot, we have three regions. Okay, so this region is corresponding to low temperature region. Okay, so they have told this is the freeze out region. This is second region is saturation region, and the region first is intrinsic region. So when we increase temperature, so what happens? So you know the band gap of n type of semiconductor is given as, so this is conduction band. Okay, this is valence band, this is conduction band. Okay, and somewhere here close to the conduction band we have donor level, and between donor level and conduction band we have Fermi level. Okay, so all the donor atoms reside here. Okay, so when we, this is the low temperature region, so this energy gap is very small. Okay, so as you increase the temperature, all the atoms sitting here, okay, all the donor atom sitting here, they'll get ionized, and the electron will move from donor level to conduction level. Okay, so suppose we have 3 donor atoms. Okay, all the 3 donor atoms will get ionized, and they will, and the electron will reach to conduction band, so it will give enhancement in the conductivity. So as you decrease the temperature, conductivity will increase. So one thing here I want to mention, see, when you increase the temperature, so in this temperature range 3, all the atom will ionize, all the donor atoms will get ionized. Okay, but this is only first level ionization. Okay, first ionization. A donor may have many levels, okay, which can provide electron to conduction band, but since you are applying low energy in this region, okay, so only first ionization will take place and all the atoms will get ionized. Okay, only first ionization will take place, but all the donor level will not get ionized. As I said in previous video, that all the donor atoms will ionized. Okay, but donor level may have many levels. Okay, and those levels are also capable to provide electron to the conduction band, but since we are applying low energy, okay, that in that case, and we require very high energy. Okay, so that energy may melt the crystal also. So here useful energy is only in this range. So when you apply this energy, all the atom will get ionized of first, this ionization is first ionization. Okay, so this temperature region also called, as I told earlier, ionization range. Okay, and slope of this graph is proportional to or equal to the donor energy level, delta E upon 2K, where delta E is donor energy level. Okay, so donor ionization energy, that is EC minus ED. Okay, if you supply this much energy, first ionization will take place. Okay, so once all the atom get ionized, okay, you don't have more electrons to increase the conductivity, because now all the atoms are ionized, and so you can break the bond here, but that require more energy. So in this temperature range, okay, this temperature range is for silicon, it comes under room temperature. Okay, so that's why silicon doped silicons are very important, because they give high conductivity or enhanced conductivity at room temperature. So once you go from region 3 to 2, okay, you increasing the temperature, but conductivity will not increase, because there are no more electron available to enhance the conductivity, because already all the atoms are get ionized. Okay, so now once you go up to region first, okay, you are increasing temperature. So now intrinsic region will come. Intrinsic region will come means now you are breaking the bond, okay, of crystal, and electron are coming directly from valence band to conduction band. Earlier electrons are coming from donor level to conduction band. So now suppose electrons are here. Okay, so these electrons will start moving to conduction band, and here we'll get holes. So this and this energy is proportional to Eg. Okay, this is our band gap. So slope of this graph, ionization region, will give you the band gap. Okay, minus Eg upon 2K. So in this question, 4 options are given. Option A is correct, because in option A is saying that slope of the graph will give you the band gap energy. Option 2, they are saying the conductivity is constant here, and the charge density is equal to the donor density, because only all the donors only providing the conductivity here. Okay, and the third option, they are told then interval 3. Okay, in interval 3, the slope of the graph will give you the this ionization energy. That is also correct. In fourth option, D, they tell you all the levels of donor atom will get ionized, but only first level ionization will take place. All the donor level will not get ionized. So A, B, and C options are correct for this question. Thank you very much.